Okay, so in this numerical test, 9E, chapter 9, okay, in class 9 physics, these 3 questions we're going to do. In this class, we'll do this 15, okay, on page 137. Open your textbook today. Do this slowly, it's not hard, but we need to be carefully listening to it, okay. So look there, 15. Let me read the question for us. An object of mass 1 kg. So here, let's take the mass of the first object, MA, 1 kg, that is fine because it's in SI unit, traveling in a straight line. Okay, so before that, maybe we can, which is not absolutely necessary as I've been saying, but let us say here, let the object that is moving, assume, okay, be moving from left side to the right. So which means if we were to give a picture, this object is moving from left side to the right side. We are assuming this way while writing final answer. It helps to understand. That's why I'm just writing. Okay, so here MA is the mass of the first object, 1 kg. And keep on going with a stick. This is an stationary wooden object. So and the mass of the wooden object which is stationary is 5 kg are the masses, okay, masses of the object that is moving, and the stationary. So this word is important here. Stationary means the object is moving a wooden block, but the wooden block is not moving. That way we'll get a clue of their velocity. So initial velocity of this object clearly mentioned there, moving velocity of 10 meters per second. So 10 meters per second is what the object is moving with, this object. And then initial velocity of the wooden object is 0 because clearly the question is saying stationary. Are the velocities, let us go slow, of the object. Okay, here you can write here respectively, so that this is mass of the first one object, this MB is the mass of the second one wooden object. So respectively will indicate that. Okay, so here are the velocities of the object and the wooden block before, respectively, okay, respectively, before collision, before they collide with each other. This is what their velocities are. Wooden, stationary, so 0, and then the object is moving with its own velocity of 10 meters per second before coming in contact or collision with the wood. Then calculate that this, they move together after collision in a straight line. Calculate the total momentum before and after impact, means collision. Okay, and then and just after the impact, also calculate the velocity of the combined object. So let's write here, let V equal to their combined velocity after collision. So after collision, they in a sort of way stick to each other and move together, so they will have same velocity after collision. Before collision, they are moving with their own velocity. Okay, this is what they're asking, and the momentum before and after collision. So total momentum, answering the first part of the question, before or after, you can calculate first, up to you. Collision or before impact, also you can use. The question is using both words, either collision or impact, to indicate coming in contact. So before is always mass of the first object into initial velocity of the first object UA plus mass of the second object would MB into its velocity UB. Final is V, initial is U, right? So we have here mass of the first object is 1 kg into UA is 10 meter per second plus MB is 5 kg wooden object into its velocity is 0 meter per second. Because this is 0, it will multiply and everything will become 0. So we are left with only 1 into 10 is 10 kg here, then this one. So this is the total momentum before that the object come in collision with the wood, okay, wooden block, and total momentum after collision, okay, after collision. After is, we know mass, momentum is always mass into velocity, just like this one. So mass of the first object into final velocity VA, but in this case they have combined velocity V. So here V, both of them have the same after they stick together, they move together, right? So MB, mass of the wooden object into combined velocity V. So we may as well write MA plus MB, and then if you want you can take this common factor V and V in front or back, it's up to you, okay? Or you can just put back like the mass into velocity. Front also it's absolutely correct. Mass of first object is 1 kg, second object is 5 kg. So V is, we don't know yet, so just write like that. So 1 plus 5 is 6 kg into V, we have equation number 2. So we have to find the total momentum before and after collision. Before we have found already, after we are not yet able, because we have to first find the value of this V, then we'll be able to find the total momentum after collision, right? So, but the law of conservation of momentum says, we'll already learned this, that according to the law of conservation of momentum, we know total momentum after collision or after coming in contact or after impact, whatever word you use is the same meaning, is equal to total momentum of the two objects before collision. It's up to you whether you write this on the left side or right side. It's up to you. Okay, so here we have here after collision, here question number 2, value is 6 kg into V equal to total momentum before collision 10 kg meter per second. And we can write here, since using equations 1 and 2. Okay, just do relaxed and giving yourself a lot of time to think and imagine, then it's easy. If you rush through it, then you tend to make mistakes and cut and then redo, and we become like confused, right? So do slowly and giving yourself a lot of space to think and imagine. Okay, so here that way is the right way to solve numericals, both in maths also and in physics also. Okay, so 10 kg meter per second is fine, divided by this 6 kg. If you shift into means it will go to the denominator and we'll cancel these 2, and 2 3s are 6, 2 5s are 10, so you're going to get 5 divided by 3 meter per second as the combined velocity. So we found the combined velocity. Let's put this 3. Don't divide now, we'll do it in the end. Okay, they ask you the combined velocity, we got it, but they're also asking total momentum before, we already found, but after also. So let us find out the value. So we write here, therefore total momentum, we write once more, before we have found 10 kg, but after collision. Okay, after collision. Okay, as I said, don't rush it, just relax and do. Okay, so here formula is after collision, same formula, so we can write here MA plus MB, we can shorten it into V here, this one. Mass of the two objects into the combined velocity is the total momentum after collision. So that will be MA is 5 kg, no, object is 1 kg, I think, yes, 1 kg, and this is 5 kg, the wooden block. Combined velocity now is here, we found out, so we're going to use that and we'll get the value of after collision also. 5 divided by 3 meter per second, and we write here since using equation number 3. So if you were to do this, then here we may just keep this value because we'll need it. That will be equal to 6 kg, 1 plus 5, 6 into 5 divided by 3 meter per second. So 3 2s are 6, so you're going to get 2 5s are 10, and here unit is of momentum is always kg meter per second, so that is correct. Equation number 4, I think it's 4 if I'm not wrong. The last one was 3, yes. So we got that this is correct because we know that according to the law of conservation of momentum, total momentum after and before should be equal. So before was 10 kg meter per second, after also we have found out to be 10 kg meter per second. So this is correct now because they should have same value. Total momentum before and after collision are always equal according to the law of conservation of momentum. We're just solving it so that we confirm it, right? So it's confirmed or proved, whatever word you like to use. Okay, so finally our answers are ready. So let's write the final answers. Go back to question. Question is saying 15 there. Calculate total momentum just before and after impact. So we write there. Therefore, total momentum just before and just after. Okay, just before or before, whatever is it, just before, and total momentum just before and just after impact, or we are using collision also, that's fine. This one just before is 10 kg meter per second according to equation 1, and just after equation number 4, same. So we write here each means 10 kg meter per second before collision, combined momentum. After collision also it's equal, and this is correct, right? And how do you know both of them are same? Using equations 1 and 4. First answer. Then second part of the answer, they're asking the combined velocity. You write here and dear question, let's see. Also calculate the velocity of combined object. Dear, or the velocity of the combined, that means the object stuck to the wood now, combined objects or object, the two now stuck after collision, is we have known that this is V, we have used V, which is equal to 5 divided by 3 meter per second. So we can go up to second place of decimal. 5 divided by 3, 3 ones are 3, and 2 remainder, right? So we write the 2 and 0.0, 3 6 are 18, 2 remainder, again point means 0. So you can go to third place if you want. Okay, 18 and 1 more, therefore then third place is enough. So we're going to get plus, no sign means plus, 1.666 meter per second, which is approximately 1.6. First, second and third place of decimal is more than 5 or more than 5, then second place will increase by 1.7, approximately this much. Okay, so we write like that, and we write here to indicate the direction as well. We can say which is positive because it's a plus number. Therefore, velocity of the combined objects, you can write your final answer, is 1.67 approximately meter per second, comma, in the original means direction of the first object, that means the moving object. After collision, both of them move, but before collision, wooden was stationary, so we started with saying the moving object was moving from left to right. Answer after combination, the answer, the velocity is still plus, means it's moving in the same direction as original direction of the first object, which is, we assumed, that is from after combine also left to right they're moving because it's plus. Had it been minus, we would have said, had this turned out to be minus, then we would have said opposite to the direction of first object, and we would have said written rather from right to left, right? So this is the first question. It's not hard, but a little bit long. Okay, you need to patiently listening and do relax, don't rush through it. Okay, that's it. Then we'll do the next two questions in the next class, after which you can take the test. Okay.